Hi everyone, this is Sangeeta working as assistant professor in IoT department. In this session, I'm going to discuss about quality of service and its various examples. So, quality of service is very important one to choose a network, right? So, how we can measure whether the particular network is good in quality? There are several parameters are there to verify or choose the network. Okay. So in that scenario, quality of service is a concept which is available in network, which means that it's an internetworking issue that has been discussed here. So based on the following characteristics, we can measure the quality of service. The flow characteristics, which is important because how the data is traversed or flow from one node to the another node. So the following things are very important in network. One is reliability, then delay, then jitter, then bandwidth. What is that reliability? These four characteristics measure the quality of network. What is that? So reliability is nothing. Whatever the data sent from the source that should be delivered at the receiving side without any damage or any error. Okay, the correct data should be what I have sent that should be delivered at the receiving side. This shows the accuracy of the data. So if the data sent is correct, we can also prefer the network is good. And delay. Delay also very important because while transmitting a packet from source to the destination, the packet gets traversed from the source node to destination node via multiple intermediate node. It may be a router, a bridge, or other node, or workstation. The data gets traversed from that node to multiple intermediate node to reach the destination. So, as a user, the negligible delay only acceptable. While transmission, there will be a queuing delay, propagation delay, transmission delay. There are a lot many delays will occur. So total delay means it includes these kind of delays. Only the negligible amount of time taken for transmission is acceptable. If the time taken is high to transmit a packet means we cannot prefer that, right? Likewise, when we download the data, that also take much time means we can also use, we cannot also prefer that. So delay also important factor here. Then jitter. If I'm sending a multiple data simultaneously, every packet should reach the destination. But the arrival of the various variable arrival of data is called jitter. The arrival rate of variable packet is called jitter. So that is also important fact because if the one message has divided into multiple sub segments, if one packet reached earlier and the second packet reached with a very large delay means we cannot accept that. So variable arrival rate is called jitter. Okay. Bandwidth. So it means that throughput. So number of data, number of bits sent per second. So it should also maximize because the network should support maximum throughput. So these four characteristics measure the quality of service. Okay. If suppose we take an example, if you want to monitor the CCTV surveillance of traffic signal, so the traffic signal, the CCTV camera footage will be important because based on the camera footage only, the fine will be sent to that not wearing helmet and other issues, right? So that time the quality of service should be enhanced. So how the quality of service can be improved? So we'll discuss the improvement techniques here. There are several techniques to improve quality of service. By scheduling the traffic also we can improve the QoS and shaping the traffic also we can improve. And we can also allocate the resource while before utilizing that. Then various admission control policies also there. So we will discuss the techniques one by one here. So first one, FIFOQ. What it actually? It is a kind of scheduling. So it's maintain a buffer. So based on the capacity of the buffer, if the large number of packets waiting in the queue means how the process, the router will serve means based on if suppose first come first serve manner means. So first inserted a packet will served first, right? So if the buffer capacity is full, if the new incoming packet has arrived, first it check whether the queue is full or not. If it's full, it discard the packet. If not, it can accept the packet in the queue and it will be departure based, after servicing. So likewise, FIFO queue will work. This is also one kind of schedule. In like different, this is a first come first serve order. So here there is no concept like a priority and a shortest job. So let me consider another category. So in this category, the based on the arrival of packet, we can classify the packet based on the priority. So some packet may have a higher priority, some packet have less priority. So based on the packet priority, the packets are categorized as a high priority queue and low priority queue, as like the previous one. The high priority queue based on the buffer, the incoming packet will be checked with the buffer capacity. If its availability is there, the packet can be stored in the buffer. Otherwise, it is discarded. And lower priority packets will store in the lower priority queue, and as like if it is full, discarded. If not, it can accommodate. So likewise, the process will serve one high priority, and after that, bus preference gives to the high priority. After that, lower priority. Okay, likewise, the priority queuing will work. Another one category also there. In this weighted fare scheduling, based on the weight, weight of the packet. So categorized into weight 3, weight 2, weight 1, likewise. So for example, I'm saying that, so whenever the packet arrives, the classifier will classify based on the weight. And as like the previous one, it is also check whether the availability of the space in the buffer. Based on that, the packet will be accommodated, otherwise discarded. So likewise, the switch will be used to move from the weight 3 to 1, likewise, so like a round robin schedule. Okay. Likewise, these techniques will work. So based on this kind of scheduling also, we can improvise the quality of service. Because if the packet having higher priority but is still waiting in the queue to serve, means we cannot prefer that. So in that kind of scenario, we will use the scheduling techniques. Then another technique, this is also very interesting one, leaky packet algorithm. So while seeing this diagram, what it looks, how this looks, the input flow is in basty flow, but the output flow at the constant rate, right? So even though the input rate is basty, so we have to regulate into constant bit rate. So that is the concept here. So here basty data comes, but the fixed data of outgoing is there. So this kind of algorithm is called leaky bucket algorithm in real-time scenario. So based on this kind of algorithm also, we can regularize the leaky packet implementation. This is also based on arrival of the packet is checked with availability of the queue. If it is full, it will discarded, and if not, the packet will be stored in the queue, and remove the packet at constant rate. Even though the incoming rate is high, the outgoing is at the constant rate, constant data rate. Okay. So likewise, the leaky bucket will work. The next, the leaky bucket algorithm shapes the traffic by bursty traffic into fixed rate traffic. It's a shaping technique. So by averaging the data rate, it's a constant bit rate to be used. It may drop the packet if the bucket is full. Yes, obviously, the bucket has full, and the bucket cannot accommodate the new packet. So the packet will be discarded. So likewise, the leaky packet will work. Then next one is token bucket. Token bucket means before reservation is a reservation based. Before transmitting data, the token will be allocated for the data. So it will also allows bursty traffic at a regulated maximum rate, but the outgoing rate at the constant rate. And the one packet is added for one packet, and then it is also check the queue availability. So one token is for first packet. The next, if the token is acquired by the packet, if so, the packet gets served, otherwise not. So likewise, the token bucket algorithm will works. Okay. Next, we will discuss in the next class. Thank you.